This video is for day 2, where we're going to be comparing two means. The first set of the notes, this is the first video, is the review of Units 8 and 9 for one sample inference for means. In Unit 8, we did a confidence interval for mu. This was used to estimate a population mean. So now we started with the checks, randomness, either an SRS or a random sample, and then we had independence. Note a randomized experiment takes care of both of those. We will start to see randomized experiments. And the check for normality, there were a few. One is you're told, this is very rare, but the population is normal. And then if you had smaller samples, let's just pretend between like 2 and 30, you're going to create a box plot and look for outliers or skew. And those notes actually go through it in a little more detail. And if n was greater than or equal to 30, you could use the central limit theorem. To calculate the interval, you need the sample mean plus or minus the critical value from the t distribution times s over the square root of n with degrees of freedom equal to n minus 1. I wanted the slash there. So it's with degrees of freedom equal to n minus 1. And then you would plug in, calculate the interval, check on your calculator using t-interval, then interpret your interval. You know, I am whatever % confident that the true mean context is between whatever your interval is. You always interpret even if the problem doesn't tell you that. Some possible follow-ups, and these would have to specifically be asked: interpret the confidence level, interpret the margin of error, interpret the standard error of the sample mean, or sampling distribution of sample means. Use the interval to comment on a claim. You'll check to see if the claim is within the interval. If the claim is within the interval, it's plausible. If the claim is not within the interval, it's not plausible. Another one is you could be asked to compare, let's say, a 90% to a 95% confidence interval. So, you know, if sample mean and sample standard deviation were the same, which is thinner, which is wider, those types of questions. The other thing was in Unit 9, we had hypothesis tests. These were used to test a claim about a population mean. And so the null hypothesis is going to be mu equals some number, some claim. The alternates could be mu is not equals to the claim. This is called two-sided. You could have mu is less than the claim, and mu is greater than the claim. Both of those are considered one-sided, because when you use TCDF to calculate the p-value, you would be only going in one direction. The checks, randomness, SRS or random sample, independence, same as always. You're going to start seeing randomized experiments taking care of both of these. And then the normality check is the same as over here. In theory, you could have the population being normal. That's exceedingly rare. But then if you have smaller samples and you have the data, create a box plot and look for outliers first and then skew. And if you have greater than or equal to 30, use the central limit theorem. Now at this point, I would actually do step 5. I would use t-test to calculate the test statistic and the p-value and write them down. Label them as test statistic and p-value. But the multiple choice is very common to see a plug-in step. So the plug-in step for the test statistic is t is equal to x bar minus mu. The mu is taken from the null hypothesis divided by s over the square root of n. with degrees of freedom is equal to n minus 1. And if you're using t-test, make sure to add the degrees of freedom. Your calculator will not do that as an output. Neither will any of the current statistical software I'm aware of. So you have to find, it usually will list n, but you have to state the degrees of freedom. And then the p-value, you would use tcdf. If your alternate is not equals to, take the absolute value of the test statistic, go greater than that, so this would be the lower bound, the upper bound, something large like 10, calculate and then multiply by 2. If it's a less than, the lower bound is something like negative 10 up to the test statistic. If it's a greater than, the lower bound is the test statistic, and then the upper bound would be something large like 10. And then you're going to make a decision about your null. Typically, we're using alpha equals 0.05, and so you would reject if the p-value is less than 0.05, or you would fail to reject if the p-value is greater than or equal to 0.05. And then draw a conclusion. The conclusion is, I do have significant evidence, or I do not have significant evidence. And then you'll talk about the alternate in context. Some possible follow-ups talking about errors. Describe a type 1 error in context. Or, based on the conclusion you made, what type of error what type of error could you have made? So if you reject, that's one word, you could have made a type 1 error. If you fail to reject, ignoring the 2, that's 2 words, type 2 error. Then you could describe it in context. You would specifically be asked if it wanted a consequence. That would need to be a separate question. You could be asked for a link to a confidence interval. The link to a confidence interval is more direct if the alternate's not equals to. So be careful for that, because a confidence interval has 2 sides. These are both one-sided. This is the 2-sided test. So, yeah, and those are the typical potential follow-ups. So, yeah, I hope that helps. I miss you guys.